Hello students, in class 9 maths we are on chapter number 8 quadrilaterals. In previous class we studied about types of quadrilaterals and some basic concepts of quadrilaterals, and in this we will start theorem number 2 based on parallelogram. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. We will use this concept in further concept also, so that if opposite sides of a quadrilateral is equal, each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. As we know that in rectangle also opposite sides are equal, but if opposite sides are equal, then we will say that it is a parallelogram, because rectangle is also a type of parallelogram. But specific condition, if diagonals are also equal, then only that quadrilateral is a rectangle, or that parallelogram is a rectangle. So if only opposite sides are, each pair of opposite sides of a quadrilateral are equal, then we can say that it is a parallelogram. We can't define rectangle according to this. Now, to prove this, given part, first of all we will draw a quadrilateral ABCD. In this quadrilateral, it's given that AB is equals to DC and AD equals to BC. The opposite sides are equal, it's given. We have to prove that ABCD is a parallelogram. To prove this is a parallelogram, we have to prove that opposite sides are parallel also. Opposite sides are equal. If these sides are parallel also, then we can say that this quadrilateral is a parallelogram. For that, it needs construction work. In construction, draw a line, a diagonal AC. Draw a diagonal AC. Now proof. In the proof, we will take triangle ABC and triangle CDA. In these two triangles, AB is equals to CD, because opposite sides it's given already. We can write it as given. AD equals to BC, that is also given part, and AC is equals to AC, common side. That means by SSS property or law, side property or side law of two triangles, triangle ABC is congruent to triangle CDA. These two triangles are congruent. AB is equals to CD, that's why we write it as CDA, and BC is equals to DA, and AC is equals to CA, the common side. And by cbse, we can write that angle CAB, this angle, is equals to angle ACD. These two triangles are congruent. Then corresponding parts of congruent triangles are also equal. Corresponding part, angle BAC is equals to angle ACD. Similarly, these two angles are also equal. So angle DAC is equals to angle ACD. But if these two angles are equal, these are the alternate interior angle, and if these are alternate interior angle, that means AB is equals to parallel to DC. But angle CAB and angle ACD are alternate interior angle. If these are alternate interior angle, that means AB is parallel to DC. Similarly, BC is parallel to AD. These two sides are also parallel. Already we write here that these two sides, opposite sides are equal. We proved that opposite sides are parallel also. That means ABCD is a parallelogram. That is the proof of our theorem number 2. Next theorem, theorem number 3. It's given that in a parallelogram opposite angles are equal. We have to prove that opposite angles of a parallelogram are equal. We studied in properties of parallelogram that opposite angles are always equal, opposite sides are equal and parallel, and diagonals bisect each other. We will prove them as a form of theorem. So to prove parallelogram, opposite angles of are equal in a parallelogram, let ABCD is a parallelogram given ABCD is a parallelogram. To prove opposite angles are equal, as we know that opposite angles means the opposite to these vertices. Angle A equals to angle C and angle B is equals to angle D. We have to prove that angle A is equals to angle C and angle B is equals to angle D. For that proof, as we know that AB is parallel to CD or DC. AB is parallel to DC. This opposite sides are always parallel and equal. It's we proved in previous theorem also. So if these two pair of sides are parallel, that means AD is a transversal. And if AD is a transversal, AD is transversal. And if AD is a transversal, then angle A plus angle D is equals to 180 because of interior angle on same side. In chapter number 6, we studied about the interior angle on same side. So these two angles are interior angle on same side of a transversal line. That's why the sum is 180. Similarly, AD is parallel to BC and AB is transversal. If it is a transversal, then again same thing, angle A plus angle B is equals to 180. Equation number 2, again same thing, interior angle on same side, have sum 180. by 1 and 2. Because of a plus d is also equals to 180, a plus b is also equals to 180. If we compare these two, angle a plus angle d is equals to angle a plus angle b. 180 180 के इक्वल है तो दोनों साइड्स इक्वल होंगी. Angle a to angle a cancel. That means angle d equals to angle b, or we can say angle b is equals to angle d. Similarly, we can prove that angle a is equals to angle c. That means the opposite angles of a parallelogram are always equal. Next theorem, theorem number 4. If in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. So in this theorem, we will go through any quadrilateral in which opposite angles are equal, each pair of opposite angles are equal, then that quadrilateral is called as a parallelogram. We will use these theorems in our exercise 8.1 and related to quadrilaterals. Whenever we want to prove that any quadrilateral is a parallelogram, so either we have to prove that opposite sides are equal and parallel, then it is a parallelogram, or we can prove that angle A equals to angle C, then also it is a parallelogram. Angle B is equals to angle D and angle A is equals to angle C. Opposite pair of opposite angles are equal, then also we can write that the quadrilateral is a parallelogram. तो इनका यूज जो है वो नेक्स्ट एक्सरसाइज में जब भी क्वेश्चंस करेंगे इनसे रिलेटेड, क्वाड्रिलेटरल से रिलेटेड, जिसमें हमें पैरेललोग्राम प्रूफ करना होगा, वी विल यूज दिस थ्योरम. सो इसके अंदर हमारे पास इट्स गिवन दैट ABCD इज ए क्वाड्रिलेटरल. Angle A is equals to angle C, angle B is equals to angle D. To prove, हमें प्रूव करना है ABCD is a parallelogram. To prove that it is a parallelogram, हमें इसमें ये प्रूफ करना पड़ेगा कि AB is parallel to DC and AD is parallel to BC. अगर opposite sides parallel आ जाती हैं, then any quadrilateral is called as a parallelogram. Proof: as we know that angle A plus angle B plus angle C plus angle D is equals to 360. The sum of the interior angles of a quadrilateral is always equals to 360. But angle C is equals to angle A, angle D is equals to angle B. That means angle A plus angle B, we can write angle A except of angle C, and we can write angle B except of angle D, because it's given angle C is equals to angle A and angle D is equals to angle B. That's why angle A plus angle A becomes 2 angle A, angle B plus angle B becomes 2 angle B is equals to 360. That means angle A plus angle B is equals to 180. The sum of these two angles, these are adjacent angles, or we can say that these are the interior angle on same side. AB is a transversal and interior angle on same sides. The sum of interior angles on the same side is equals to 180. If interior angle on same side is supplementary, that means AD is parallel to BC. Similarly, second part we can prove as according to this only. So directly we will write here, similarly we can prove AB is parallel to DC, hence ABCD is a parallelogram, which we have to prove in this theorem. Next theorem, you have to prove that the diagonals of parallelogram bisect each other. In this condition, it's given that there is a parallelogram ABCD is a parallelogram given ABCD is a parallelogram and AC and BD intersect at O, and diagonal AC and BD intersect at O. To prove diagonal bisect each other, or bisect means equally divided. OA equals to OC and OB is equals to OD. We have to prove this. For proof, take the triangles, triangle AOD and triangle COB. In these two triangles AOD and COD, as we know that AD is equals to BC because ABCD is a parallelogram. If it is a parallelogram, then opposite sides are parallel and equal. That means AD and BC are equal, and AD is parallel to BC. If AD is parallel to BC, that means this angle and this angle are equal because of alternate interior angle. Angle DAO is equals to angle BCO. Similarly, this angle and this angle are also equal. That means angle ADO equals to angle CBO because of alternate interior angle. If these angles are equal and common side between these two angles are equal, then by SAS property or SAS rule of congruency, triangle AOD is congruent to triangle COB, and if these two triangles are congruent, then by CPCT, corresponding parts of congruent triangles, we can say that OA is equals to OC and OB is equals to OD. That means if it is a parallelogram, then their diagonals bisect each other, they divide each other in equal two parts. That is our theorem number 5. In next video we will go for some new theorems, and with that exercise 8.1. For today, thank you.